Network availability. Finally, network management plays a significant role in improving certain properties of the network itself that increase the network's effectiveness and value. Of course, it might be argued that this additional value can be translated into additional revenues and hence be subsumed under the previous category, which have discussed a while ago, the enabling of revenues. Nevertheless, this aspect is relevant enough to stand on its own. The most important aspect here concerns network availability. To improve network availability, a network provider might decide to invest in highly available networking equipment at a cost. However, an equivalent or even greater impact on network availability can, in many cases, be achieved by investing in network management instead. Network management plays a significant role in reducing the number of errors that network operators and administrators make and that can lead to unintentional outages. An example is a service that is accidentally improperly configured, or the application of conflicting configurations to network devices that cause communications to be disrupted. Service provisioning and policy-based management are just two of the many techniques that contribute this way to a network availability. In addition, network management can help reduce the impact that operational errors can have on the network and recover from those errors. During operations, network management plays a major part in being able to spot impending trouble quickly and thereby ideally enables preventive action before problems occur. Performance trending and threshold crossing alerting are examples of techniques that can be applied. Likewise, when failures do occur, network management facilitates quick identification of failure root causes and corrective action. Trading off the benefits and cost of network management investments. Of course, network management's positive impact described previously is partly offset by the cost of network management itself. The cost for additional operational support infrastructure, and to a much lesser extent, the additional management traffic and load on network devices that could otherwise be used for production traffic. Clearly, investment in network management technology needs to be directed in such a way that the incremental return exceeds the incremental cost. This incremental return consists of reductions in operational expense, increases in revenue, and increases in the network's value, which can be translated into some monetary value. In addition to the immediate return, other factors need to be taken into consideration. One such factor concerns the cost of managing the operations support infrastructure itself as the underlying network evolves. This needs to be undertaken into account as also as part of the decision for the network investment itself. A second factor concerns economies of scale. Network management needs for a smaller network are not proportionally less than for a larger network. Of course, the scale is smaller, but the management functions that need to be provided and systems that require investment to support them in many cases might be largely the same as for the larger network. All other factors being equal, the incremental cost of network management should hence be expected to decrease as the scale of the network grows. Again, this could impact investment decisions. An investment that might not be feasible for a smaller network might become more feasible for a larger one because it can be amortized over a larger number of devices, or ports, or instances of end-user services, or whatever measure for network scale is used. Chapter Summary. Network management is done not for its own sake, but to make network systems and communication services run smoothly and efficiently. In the end, as interesting as network management is, as a technology, the drivers behind it boil down to money. Hence, when dealing with network management, it is important to always keep this aspect in mind and understand the business ramifications of management technology. Management technology needs to be effective, which means that it provides tangible benefits for a network provider and delivers a good bang for the buck. In this final chapter, we took a closer look at those aspects. One of the takeaways should be that network management is not just about reducing cost of ownership. It is also about revenues, of course more so for service providers than for enterprise IT departments, about availability, and about getting the most out of your investment in communication services and technology. The effectiveness of management is influenced at every level at which management interactions occur, by the managed devices and systems and how manageable they are, by the operation support infrastructure and management systems and how productive they make their users, and by the management organization itself. Many factors contribute to management's bottom line. To assess the effectiveness of management metrics are needed. Although there is no single established way to measure management in an objective manner, many metrics can be applied, both to measure management's business impacts and to measure the effectiveness of different factors in management that are known to contribute to that impact. In addition to established measures for aspects such as scale and availability, many of the most relevant metrics are custom developed to pertain to the particular context in which management occurs. For example, related to the efficiency of specific management tasks, in the end, such metrics can be used to track efficiency gains over time and to help direct investment as well as technical decisions concerning management technology. The chapter review. In what ways can network management impact a service provider's business? Give an example of a network management technology or feature that can affect revenue. Give an example of a network management technology that can affect availability. At what levels can the effectiveness of network management be assessed? Name the two different contexts in which an elaborate GUI of a management application does very little to increase management effectiveness. Imagine that you have decided to invest in the development of custom rules for your event correlation system. The goal is to improve automated diagnosis of failures in the network. The development can be carried out by one consultant who can incrementally introduce new rules into the system, which will make the system gradually more effective. You decide to give it a try, but you want to make continuation of the project dependent on it, indeed, fulfilling your expectations as you go along. Can you think of some metrics to use to assess whether the system fulfills expectations? Imagine that you need to decide whether to invest in a new service provisioning system. That system is expected to carry a significant price tag, in particular, when taking into account the cost of integrating the new system with the existing operation support infrastructure. What metrics might help you decide whether this is a worthwhile investment, and how will you do the math to arrive at a go, no-go decision? What is the difference between MTBF and availability? Which three aspects determine the complexity of operational tasks? A management application vendor boasts about the scale of its management system, claiming that it can support 10 million managed objects. What are some questions that you might want to ask in return? This is the chapter review. Thank you.